Assalamu alaikum and welcome to my channel Chemistry for All by Ayaz. Today we will discuss a topic, a chapter which is included in class second year chemistry, that is called as aromatics. So today we will discuss aromatics, its history, the first member of aromatics, which is called as benzene. So first we will discuss aromatics, that how this word came into chemistry, in the field of chemistry, in the field of science. So the word aromatic is actually derived from a Greek word which means aroma. It is derived from aroma. Aroma is a Greek word which means pleasant odor or fragrance. So the first compound which was isolated, that was benzene, and the aromatics was first defined by different scientists, that those compounds which have pleasant odor, those compounds which have fragrance, they are actually called as aromatics. So the first member of all aromatic family was benzene, which was derived by Michael Faraday from coal tar. So that was named as benzene. Benzene is the first member of all aromatics. Its chemical formula is C6 and H6. It contains 6 carbon and 6 hydrogen atoms. If we go to the structure formula of benzene, so it has hexagonal shape. We can arrange the pi bond in this way by alternate single and double bond. At each corner we have carbon, and to each carbon one hydrogen atom is attached. That is the structure of benzene, and that was the first aromatic which was isolated from coal tar by Michael Faraday. So those compounds, initially the aromatics were defined as those compounds which have fragrance, those compounds which have pleasant odor are called as aromatics. You can draw the shape of benzene in this way, that the pi molecular cloud are the 3 pi bonds put in a circular form. Okay, so this is called as pi electronic cloud, or it is also called as benzene nucleus. So that was a little bit history about the aromatics, that the aromatic word was derived from a Greek word aroma, which means pleasant odor or fragrance. So those compounds which have fragrance or pleasant odor, they will be called as aromatics. The first member of all aromatics was benzene, which was derived by Michael Faraday from coal tar. Now the concept was changed from pleasant odor towards some different chemical behavior, because some other compounds were isolated which were still aromatic but they had no pleasant odor. So ये definition जो है, their definition was changed from the pleasant odor. Nowadays we can define aromatics in two ways. The most modern definition of all aromatics, those compounds whose chemical behavior is similar to benzene ring. Those compounds whose chemical behavior is similar to benzene ring are also called as aromatics. That is the first definition on the basis of chemical behavior. Now what does it mean by this chemical behavior? Chemical behavior means the chemical properties, the chemical reaction, the shape, the structure. Those compounds which have same chemical behavior, those compounds which have same chemical properties to benzene, they are also called as aromatics. Or we can also define that benzene and its derivatives. Benzene and its derivative. Now what does it mean? Those compounds which are isolated from benzene, which are derived from benzene, which are formed from benzene. Benzene was the first compound of all aromatics. Now those compounds which are formed from benzene will be also called as aromatics. So benzene and its derivatives are also called as aromatic. That is the second definition. So we can define aromatics by two ways. The first one is those compounds whose chemical behavior is similar to benzene ring are called as aromatics. Are those compounds benzene and their derivative or benzene and its derivative, benzene और benzene से बनने वाले कंपाउंड भी एरोमेटिक का हिस्सा है. सो सबसे पहले हम डिस्कस करेंगे कि benzene and its derivatives. First we will discuss the nomenclature of aromatics. In nomenclature we will discuss two or three main types of aromatics. First one is called as mono-substituted benzene derivatives. Mono-substituted benzene derivatives means what? Mono-substituted benzene derivatives are those compounds in which one hydrogen is replaced from benzene. If I write in this way, this is the structure of benzene. If we remove hydrogen from either side and put atom say X to benzene, we can attach this X on either side because all the 6 hydrogen are similar. So we can put here, here and onto each side. This is called as mono-substituted benzene derivatives, in which we have replaced a single hydrogen, one hydrogen from benzene ring, and we attach another atom instead of hydrogen. Then it is called as mono-substituted. Substituted is derived from substitution. In substitution reaction, we can replace, we can displace some atoms from a molecule, from a compound, and other atoms comes and attach on that side of the molecule. Therefore, they are called as mono-substituted benzene derivatives. In mono-substituted benzene derivatives, we can name the molecules by different ways. Suppose if we remove a hydrogen atom from benzene and we attach a bromine, then this is called as prefix. First, it will come first, therefore it is called as prefix, and the benzene name itself will be used as suffix. Suffix will be used as a parent name, and that will be used as a daughter name. So we will add the daughter name first, followed by the word benzene, which is the suffix or the parent name. So this is bromine, but here we will not write as a bromine because this prefix will be used as O. O comes in the last of this bromine, so it becomes bromo. Bromo is the prefix or the daughter which is attached to the benzene, and the parent name is benzene. So this compound name is bromobenzene. Bromobenzene is a mono-substituted benzene derivative. Why? Because we have replaced one hydrogen from this side and we have attached a halogen, a halo member of the group 7. Therefore, it is called as bromobenzene. Now, if I replace hydrogen with iodine, then it is called as iodobenzene. That is the mono-substituted benzene derivative. If I replace hydrogen and I attach NO2, then it is called as nitrobenzene. Nitrobenzene will be, because this is nitro group and it is attached to the parent chain. Parent chain is benzene, that is the suffix, so its name will be nitrobenzene. That is called as mono-substituted benzene derivatives, and these names are used in the IUPAC system as well as in the common system. Now, during the discussion of aromatics, we have some special names, and the special names will be used in the common system as well as they have been accepted by the IUPAC system. Now those special names, common names, will be used as a suffix, as a parent name. Suppose if I attach a methyl group to benzene, then its name is not as a methyl benzene. Its special name is something different, and its special name is toluene. So the whole compound is known as toluene. It means toluene is the special name as well as IUPAC name, as well as common name. So toluene is the special name that will be memorized. If I attach NH2, as we know that NH2 is the functional group of amine family, then it is not aminobenzene, then it is called as aniline. Aniline will be the special name of this compound. In the same way, we can attach SO3H. SO3H is called as sulfonic group. So this is not sulfone benzene. This is called as benzene. Now we will write benzene before the prefix, benzene sulfonic acid. That are some special names. So these special names will be memorized, and that will be used as a parent name. Now if we attach iodine here at second position, then it is called as iodo-toluene. Why? Because the whole compound is named as toluene and we have attached iodine with toluene, therefore that is called as iodo-toluene. So this special name will be memorized, and that will be used for further nomenclature in the di-substituted benzene derivatives, in the polysubstituted tri, tetra, penta and hexa. In the same way, that is the functional group C double bond OH. This functional group is belongs to the family of carboxylic acid. So if this functional group is attached to benzene, then it is called as benzoic acid. Now the benzoic acid is the whole name of this compound due to the attachment of the carboxylic acid. Its special name, common name, IUPAC name is benzoic acid. Benzoic acid is a suffix, it is a parent name, it will be used in the last. If we attach here bromine, then it is called as bromobenzoic acid. In the same way, if I attach this group, now if we look to this functional group, C double bond O, at one side alkyl group, at the other side aryl group, then it is the family of ketone family. So this compound now belongs to ketone. So this is aromatic ketone actually, and this aromatic ketone is called as acetophenone. So acetophenone is the special name, IUPAC name, common name, and that will be as a parent name will be used. Now if we attach OH group, OH group, you know, OH group is the functional group of alcohol family, and if we attach the functional group of alcohol to benzene ring, then it is called as aromatic alcohol. And if we attach this OH to any carbon atom, then this is called as aliphatic alcohol. This is simple alcohol, ethyl alcohol, ethanol. This is aliphatic chain, and this is aromatic ring. So aromatic alcohol is different from aliphatic alcohol. Therefore, its special name is used as a phenol. So it means phenol will be used as a parent name. Now if we attach bromine, chlorine or some other compound to phenol, so phenol comes in the last. That will be bromophenol, iodophenol, nitrophenol, chlorophenol and so on. That is the first nomenclature of aromatics, in which we have used two things, that is special names and the parent name. The special name will be always used as a parent name. Now if we attach two different groups or same groups to benzene, so what we will do? For that purpose, we will discuss three things, that is di-substituted benzene. So it has been clear that first mono-substituted will be formed. After mono-substituted, di, tri, tetra, penta and hexa will be formed. So it depends upon totally on the mono-substituted group, that what type of the mono-substituted group is attached to benzene ring. Then we can attach some other groups to these sides like 1, 2, 3, 4, 5 and 6. Now if we look to the 2 position and 6 position, 3 and 5, 4 and 1. So 2 is equal to 6. दो और चीज दोनों पोजीशन सेम है और इसको हम कहेंगे आर्थो पोजीशन. आर्थो इज रिप्रेजेंटेड बाय O. 3 and 5 both are same. If we attach an atom at 3 or at 5, both are same. These positions are called as meta position, which is represented by M. This 4 position is very unique position. Why it is unique? Because already a mono-substituted derivative has been formed. So 4 is called as unique position and this is called as pair P. Now this ortho meta para. Ortho meta para will be used in the common system. If we are discussing common system of aromatics, of benzene, of all aromatic family, then this ortho, this meta and this para position will be used. When it will be used? When there are two groups, then we can use ortho, meta and para. If we have one group, then that will be special or IUPAC name. If we have more than two groups, then there will be no ortho, meta and para position. This ortho, meta and para position will be used when there are two groups. So in common system, we can use these three positions. While in the IUPAC system, we count the longest continuous chain, which is represented by digits, which starts from 1 and 2, 3, so on. So now we will discuss these three positions one by one. Now if we look to this compound, if I attach bromine here, this is called as mono-substituted benzene derivative. Now I want to replace a hydrogen from ortho position, from this position or from this position. These two positions are same. So if I attach another bromine here, this is called as ortho and this is also called as ortho position. Next to ortho is called as meta. Next to meta is called as para. जरूरी नहीं कि भाई इसी तरह पोजीशन है. Next to ortho, that position will be called as meta, that any position. But next to ortho will be meta, next to meta will be called as para. The chain may be horizontal, this structure may be vertical, but the first group which is already attached is called as mono-substituted benzene, and the second group we have attached at ortho position. Now we have two bromine, one at first and the other at second position, and this second position is called as ortho. So you can use the symbol of ortho, which is O, then a dash. Now we have 2, so for 2 we can use di, and that is bromo. So ortho, di, bromo and benzene will be used in the last. Now we can change its position from ortho towards meta, from meta towards para. So if we attach here this bromine, that will be called as mono-substituted benzene derivative. Now I can attach another at meta position. Now we have two bromine. So the second is attached at meta position. Therefore this position will be specified. Why? Because this is already mono-substituted benzene derivative, which is called as bromobenzene. So there is no need to specify its position. The second group will be specified, that is at meta position. So we can write the symbol of meta, which is small m and dash, and then we will dibromo, and the last we will use benzene. So this is called as meta dibromobenzene. We can also change the position from meta towards para, which I have told that is a unique position, that is bromobenzene. Okay, that is mono substituted first compound which is formed. Now I can attach here at para position, that is also bromine. So that is unique, which is called as para. So I can use the symbol of para, which is small p and dash, and we have two bromine, so dibromobenzene. Ortho, meta and para will be used in the common system. 1, 2, 3 and so on will be used in the IUPAC system. If we have two groups attached to benzene ring, then we will use ortho, meta and para position. Therefore, ortho, meta and para position will be used in the common system, not in the IUPAC system. Okay, that is the di-substituted benzene derivative system, that if we have two groups attached to benzene ring, how we can name to the compound. If we name the IUPAC system, then we will use here from 1. We can also use 1 here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So one bromine is attached at one position. The second is attached at second position. So we will write 1, 2. And how many di? Di used for 2. Dibromobenzene. If we come and look here, 1, 2, 3, or 1, 2, 3, clockwise, anti-clockwise, we can go. So one bromine is attached at one position, the other is attached at 3 position. So as the IUPAC system of this compound will be 1, 3 dibromobenzene, and 1, 2, 3, 4, or 1, 2, 3, 4. From either side we can count. In the IUPAC system we can use 1, 2, 3 and so on, that is digits. So one bromine is attached at first position and the second is attached at fourth position, then it becomes 1, 4 dibromobenzene. That is the di-substituted benzene derivative common system as well as IUPAC system. Now if we have two different groups attached to benzene ring, then what will be done? If we attach two different groups, suppose I attach a bromine here and a chlorine here. Now how we will use the naming system, the nomenclature for this compound? In bromine there is B, in chlorine there is C. B comes first, then C in alphabets. So alphabetical arrangement will be followed for this compound. So we will start 1, 2, 3, 4, 5, 6. Clockwise we can't come clockwise. Why? Because the second substituted will be designated as the lowest possible number. So 2 comes here. Now we will start from bromine, not from chlorine, because bromine is alphabetically comes first. So 1 bromo, 2 chloro, and benzene will be used in the last. That is the IUPAC system for di-substituted benzene derivatives. If we have two different substituents, then what we will do? We will do according to this system. If I write OH, that is the mono-substituted benzene derivative, this OH is the special name and this compound name is phenol. Now if I attach bromine here, it becomes di-substituted. So in the common system we can write ortho. This is ortho position. This is ortho position. O से represent करते हैं. So it becomes ortho bromophenol. If we use the IUPAC system, we can count from the special group. Special group is the hydroxyl group that will be represented at first position. So we will start from here 1, 2, 3, 4, 5, 6. 2 bromophenol will be the IUPAC system. In the same way, we have some special names for di-substituted benzene derivative. Just like we have discussed some special name for mono-substituted benzene derivative. So we have also some special names for di-substituted benzene derivative. Suppose if I attach one methyl group, then it is not methyl benzene, it is called styrene. The second is attached here, then it is called as xylene. Now this compound name is xylene. But the second substituent is attached at ortho position. This is called as orthoxylene. It comes here, then it is called as metaxylene. It comes here, then it is called as paraxylene. तो xylene कब होगा? xylene तब होगा जब हमारे पास both are methyl groups are attached, then its special name is called as xylene, and the IUPAC name 1,2-dimethylbenzene, 1,2-dimethylbenzene. And in the same way, paraxylene, that one methyl come here and the other a para position, then it is called as paraxylene. So these are some special names. The special names are di-substituted benzene derivatives. In the same way, you can write some other special names. Just like we can attach OH to benzene ring, then it is called as what? Then it is called as phenol. Now we can attach OH group here, and if I attach OH to benzene ring, then it is called as phenol. I can attach this OH at meta position. If this is OH, I can attach OH at para position. Now we have just changed the position of second hydroxyl group, second functional group, which is the functional group of alcohol family. So this is called as phenol. Now the special name of this compound is different. If we write catechol, this is called as resorcinol. This is called as hydrophenol. OL comes in the last. That is IUPAC system. Catechol, resorcinol, hydrophenol. These are the special names. These are the common names. Now if we use the IUPAC system, I will write 1, 2, 3, 4, 5, 6. One OH is attached at first position, the second is attached at second position. So it becomes 1,2-dihydroxybenzene, 1,3-dihydroxybenzene, 1,4-dihydroxybenzene. That will be used in the IUPAC system, and these are some common system. Common system or special system. So special groups and special names have been accepted with the IUPAC system, therefore that will be accepted. In today's lecture, we have discussed the history of aromatic compound a little bit, mono-substituted benzene derivative nomenclature, di-substituted benzene derivative. In the upcoming lecture, inshallah, we will discuss poly-substituted benzene derivatives, their chemical behavior, and some other compound. So please subscribe my channel Chemistry for All by Ayaz. Thank you so much.